Good morning, everyone. I think only 27, including me. That means only 25 students are there still. Okay. Have you solved the example that I have given you in the last lecture?
Ma'am,
Yes,
please
ma'am.
show us to how to solve, ma'am.
How to solve? Hmm. I think it is with two constants, no? C1, C2.
Yes, ma'am.
Okay, let us solve this. You can solve with me only. Uh, what was the question? Find the value of lambda for which the integral equation has a non-trivial solution. Okay. What is the equation we have?
Integral 0 to 1 6x minus t into y of t dt.
Okay. Let me write down that. Y of x is equals to lambda integration 0 to 1 6x minus t into y of t dt. Okay, we have to find out the non-trivial solution because always there exists a trivial solution, that is y of x is equal to 0 is a by default solution, or we can say it is a trivial solution which always exists. Just like for a group always there are what you can say about simple group. What do you mean by simple?
Uh, a group which does not have maximal subgroup.
No. Okay, let me go for this one because otherwise we will waste the time for discussing that. आठवत आहे का कुणाला सिंपल ग्रुप?
No proper
Having no
non-trivial.
proper maximal subgroup.
हाँ, no proper
Normal subgroup.
normal subgroups. I don't know where from where Eros you seen the definition. Maximal subgroup means
No, ma'am, it is normal.
correct. It is normal, na. Let us go for solving this. Y of x is equals to lambda. Then what we have to do? Simply we are going to write down this as integration 0 to 1 6x y of t dt minus this lambda as it is integration 0 to 1 ty of t dt. Okay. Now what you have to do? We have to take the terms of x outside the integration since integration is with respect to t. Okay. This 6 also we can take outside integration 0 to 1 y of t dt minus lambda integration 0 to 1 ty of t dt. Okay. So on the next step, what we can do is this 6x lambda, whatever we have. After this, whatever the term we are getting this is inside the integration and within the limit 0 to 1. This is also inside the integration within the limit 0 to 1. So obviously there may be some constant. Okay. So now this is what our given equation. Let me name this as say equation 1. Here let us name this as 2 and let me name this C1 is nothing but 0 to 1 y of t dt. This is what your equation number 3. C2 is equal to integration 0 to 1 ty of t dt, and this is your equation number 4. Okay. Now if I want to solve this equation, that means if you want to solve this equation 2, we have to solve it for different value. That means we have to solve so that we can get the values of C1 and C2. Okay, after getting the values of C1 and C2, we can solve that value of a d lambda, that is a coefficient matrix which is equal to 0 or not equal to 0. If it is non-zero, obviously we can say that C1 and C2 are equal to 0. But we are not interested in C1, C2 equal to 0. We are interested for non-trivial solution. That means we are going to take d lambda equal to 0. Okay. So let us solve these equations. Now for that we must know what is y of t. So wherever you are having x, just you have to put it as t and you have to use equation 2 by using x is equals to t in the values of c1 and c2. Okay. So let us solve these two equations. First I will solve this one. C1 is equal to integration 0 to 1. What is y of t? It will be nothing but 6t lambda c1 minus lambda c2, and this dt will be as it is. Similarly, we can work for c2 is equal to integration 0 to 1 t. The value of y of t we can write from equation 2. Substituting wherever you are having x, you have to replace it by t and you can write the value of y of t in this dt. Okay. Now let us try to solve this. This integration is easy to solve, correct? Now what you have to do simply, this 6 lambda c1 all are constant. What will be the value of integration? Simply
T
t
square
minus lambda c2.
into T.
What is it? Simply t.
Yes.
And now take this
Within
inside
0 to 1.
within the limit 0 to 1. Okay. C2 is equal to, what is the integration now? It is 6 lambda c1 outside t square it is, so
T cube
cube
upon 3
upon, correct, minus
minus
lambda c2,
to T.
uh, as it is t, so integration of t will be t square by 2.
2. Within
Calculate
limit
all
0
these
to 1.
values within the limit 0 to 1. Okay, so the next step it is we have to put the values. Okay, 6 lambda c1 upon 2, t is 1, minus lambda c2 1. Again if you are going to put the value 0 minus, you will get again 0, so no need to consider that. And then we can write down for c2 6 lambda c1 upon 3 minus lambda c2 upon 2, minus again if you put 0, it will be equal to uh, t square, that is 0 square 0 cube, again it will be 0. Okay, now we have two equations. Let me name this as say equation A and this is say B. Just like we have renamed this as A1, A2 in our method. A1, A2, A3 up to AN we are having equation. Those equations we have written, and now here we have to solve these two equations for finding the values of C1 and C2. Right? So let us just simplify these equations. If I take C1 outside, what will be the resultant? 1 minus this will be simply 3 lambda, correct? So this C1 is already outside. Now this minus will be plus lambda C2 is equal to 0. This is our equation A. And if I take a C2 outside from this, first let me write down the value of a C1. Right. So what is a C1 as it is with negative sign? So here it will be positive lambda C2 upon 2. Okay, sorry. You have to take the value of a C1. So it is 2 lambda C1 with negative sign. Okay, plus C2 if I take common, it will be 1 minus lambda upon 2 is equals to 0. Thus simply we are going to simplify the equations A and B. Okay. So this 3 2s are 6 and this will be 2 lambda c1 with negative sign, and this c2 if I take outside it will be 1, and here this is with negative sign. So if I want to write down here it will be positive. So here this will be with positive sign. So here it will be negative minus 3 lambda and this c1 outside, and this minus will be plus, and this is lambda c2. Okay. Now these are the two equations in two unknown, that is C1 and C2. Now we can solve this equation directly, or you can solve it by Cramer's rule. Yes, anyone remember Cramer's rule for finding the values?
Ma'am, we consider the determinant dx dy and
Uh,
determinant of constant d.
so if I want to find out the value of x, it is nothing but dx upon d. And if I want to find out the value of y, it was dy upon d. Those you have studied in your, I think, 10th, in the 10th standard, it was there, how to find out the values by using Cramer's rule. So instead of using this x, we have to use for C1 and C2. Okay. So you can solve by that method, or you can simply use a multipliers and then you can evaluate. Or in another way, we can directly go for finding the value of d lambda. First, we'll find out the value of d lambda and we'll equate it to 0. Why we are going to equate it to 0? Because we want to find out the non-trivial solution. Okay. So what is the coefficient of C1 is 1 minus 3 lambda. Similarly, now what is the coefficient of C2 in the first equation is lambda. And here it is minus 2 lambda, coefficient of C1. Coefficient of C2 is 1 plus lambda by 2. Okay. So let me solve this determinant 1 minus 3 lambda into 1 plus lambda by 2 plus 2 lambda square is equals to 0. Okay, now let us solve this equation. 1 plus lambda by 2 minus 3 lambda minus 3 lambda square by 2. Okay, 1 plus lambda by 2 minus 3 lambda minus 3 lambda square by 2 plus 2 lambda square is equals to 0. Okay. Let us solve this. If I take a lambda outside, what will be the resultant? 1 by 2 minus 3. We have to solve this one. So what will be the resultant of this? Minus 5 by 2. So it will be 1 minus 5 upon 2 lambda. Correct? Okay. If I take a lambda square outside, what will be the resultant? 2 minus 3 by 2. That will be nothing but 1 by 2. Okay.
Minus 1 by 2, ma'am.
Is it minus 1 by 2? If I am going to take a lambda square outside, it will be 2 minus 3 by 2, no?
Yeah.
So what is the value of 2 minus 3 by 2? 2 minus 1 by 1, will be half.
Yes, ma'am.
Oh, okay. Now if I want to solve this equation, I will multiply by 2. So what I get is lambda square minus 5 lambda plus 2 is equals to 0. You can solve this by using our b square minus 4ac formula. Minus b means it will be plus 5 plus or minus b square means
25.
4ac,
8
right,
upon
divided
2.
by 2. So what I get the value is it will be 5 plus or minus. So 25 minus 8, what will be the value?
70.
Correct. It is under root 17 divided by 2. So how many values of lambda we are getting is 2. First is 5 plus under root 17. Second is 5 minus under root 17 divided by 2. Actually, what was our question? We have to find out the values of lambda so that we can get a non-trivial solution. And we are going to get a non-trivial solution since we have assumed that the coefficient matrix d lambda is equals to 0. If it is equal to 0, then only we are getting the non-trivial solution. And if it is not equal to 0, we will get the trivial solution, that is C1 and C2 are equal to 0. Okay. So now you can say for non-trivial solution of this equation, we get the values of lambda are 5 plus under root 17 by 2 and 5 minus under root 17 by 2. And if you want to further work, so what you can do is first you have to write down these. Okay. This will be lambda 1 is equals to 5 plus under root 17 by 2. Lambda 2 is equals to 5 minus under root 17 by 2. Okay. what will be our next step? We have to now resubstitute all these values. Now what we can do is first we have to work for lambda 1. Put lambda 1 in the equations A and B. What are our equations A and B? These are nothing but the equations we have obtained by using the our values of C1 and C2. This is what from equation 2, the values of C1 and C2 we have taken. Then we have solved the equation 3 and 4. Then we get the values of A and B. That is equation A and B. Now, what we have to do, we have to put up the value of lambda 1 in both the equations, and then you can get the values of C1 and C2. Okay. Have you written up to this? Niletka,
Yes, ma'am. Yes, ma'am.
if written, let us solve this. Actually, the question was up to this to find out the lambda, but now we will find out the values of C1 and C2 also. Okay. So put up the value of lambda 1 in our equation A and B. What is our equation A? C1 1 minus 3 lambda plus lambda C2. Okay, wherever you are having a lambda, you have to put it a value of a lambda 1. This will be C1 1 minus 3. Value of a lambda 1 you can put, and plus value of a lambda 1 C2 is equals to 0. Okay. Similarly, we have to put it in equation B. Okay, what is our equation B? Minus 2 lambda C1 plus C2 minus 2 lambda C1 plus C2 1 plus lambda by 2. Correct. This is our equation B. So now what you have to do? We have to put up the value of a lambda 1 in this equation. Okay. And as it is somewhat complicated to solve because it is with under root 17. Right. You can put it as it is because what is the question? We have to find out the values of lambda for which we are going to get a non-trivial solution, and hence you can put up the result like this also, or if the question is like this, find the values of C1 and C2, then you have to solve this equation after putting the values of lambda. What you have to do is minus 2 value for lambda 1 you have to put plus C2 1 plus value for lambda divided by 2, which is equal to 0. Now you have to solve these two equations for values of C1 and C2. Similarly, what will be the next step? Put up the value for lambda 2 in equations A and B. Correct? And then you will get some another solutions. Okay? First step, what we have done? We have just taken our equation and we have just taken our terms of x outside the integration, as integration is with respect to t. Then we have put up the values of C1 and C2. Then we have found the values of C1 and C2. Put up the value of equation 2 in terms of t in C1 and C2. Solve this and you will get two equation in two unknown, that is C1 and C2. And this is what we will get the non-trivial solution. That means why? Because we are getting non-trivial solution since value of a d lambda is equal to 0. So you can say now for these values of lambda we are getting the non-trivial solution. Okay. Is there any doubt?
No, ma'am.
Okay, let us solve the one more example for C1 and C2. We write this example: y of x is equals to lambda integration 0 to 2 pi. Up to now we were solving about 0 to 1 now. So it may be some other limits also, x plus t y of t dt. Okay. Actually the answer for this is lambda is equals to plus or minus pi. Here also we have to simply find out the non-trivial solution. Okay. For which values of lambda we are getting the non-trivial solution. That means you have to evaluate the value for d lambda, that is a coefficient matrix we have to find, and then we have to find out the determinant of coefficient matrix which is equated to 0, and hence we will get the values of lambda. Okay. Now let us solve this one. Okay. What will be the resultant? Sin x cos t. We have to use a formula for sine of a plus b plus cos x sin t y of t dt. Okay, which is equals to lambda. In if I am going to take the values of x, that means terms of x outside, it will be 0 to 2 pi cos of t y of t dt. Correct? Plus lambda integration. Before integration, we have to take the terms of x outside. This is with cos x integration 0 to 2 pi sin t y of t dt. Okay, now this is what a value of a first constant C1 plus lambda cos x C2. This is our given equation number 1 and this is our equation 2. Now you have the values of C1 is equal to 0 to 2 pi cos of t y of t dt. Similarly, we have the equation C2 is equals to integration 0 to 2 pi sin t y of t dt. You can name this as equation say 3 and 4. Now you have to solve the equation 3 and 4 by using equation 2 in terms of t. Okay. Right after this, then we will solve C1 and C2. Written after this?
Yes, ma'am.
Now let us solve for substituting the value of y. C1 is equal to integration 0 to 2 pi cos of t. Then you have to substitute the value of y of t. What is the value of y of t? This lambda sin t c1 plus lambda cos t c2 y of t value we have written dt. Okay, so let us solve this equation. This equation 4 we will solve later on. You can write the statement here, solving equation 3 and 4 by using equation 2. C1 is equal to, okay, what are the constant term? Lambda C1 outside integration 0 to 2 pi cos of t sin t dt plus lambda C2 integration 0 to 2 pi cos square t dt. Okay. Now what we have to do, we have to use the cos and sin formula so that we can evaluate easily. We can multiply and divide by 2, so it will be, if I am going to multiply and divide by 2, it will be 2 sin t cos t, that will be sin of 2t dt plus lambda C2, what is the value of cos square, it will be 1 plus cos of 2t divided by 2, it is nothing but 1 plus cos 2t is 2 cos square t. Okay, now you can solve the integration. What is the integration of sine? It will be cos of 2t divided by 2 with a negative sign, correct? Plus lambda C2 divided by 2, integration of 1 is t plus integration of cos is sine 2t upon 2 within the limits 0 to 2 pi. This now minus sign we can take common, and this will be 2 into 2, 4. What is the value of cos of 4 pi? After substituting 2 pi here, it will be cos 4 pi minus t0 cos 0 plus lambda C2 upon 2. Let me substitute here. 2 pi minus 0, no need to write down the value 0. So here it is 1 by 2, again sine 4 pi minus sine 0. सांगा cos 4 pi चे व्हॅल्यू काय येणार आहे?
1.
Correct. 1 minus 1, it will be 0 plus lambda C2 upon 2, it will be 2 pi plus 1 upon 2, again what is sine n pi? 0. Sine 0 is 0. Correct? नक्की ना cos 4 pi का value? C1 is equals to, we get the first term is 0. So what I get the value is lambda C2 upon 2 into 2 pi. This is again 0. So this 2 get cancelled. We get it is lambda C2 pi. So what is our equation? C1 minus lambda C2 pi is equal to 0. Okay. Written after this, let me solve the equation C2. What is C2? Integration 0 to 2 pi sin t y of t dt. Okay, let us try to solve the value of C2 is equals to integration 0 to 2 pi sin t. Let me put up the value of y of t here. What is y of t? Lambda C1 sin t plus lambda C2 cos t dt. integration 0 to 2 pi lambda c1 outside. What is sine square t? Now if I want to find out integration of sine square t, I have to convert this now. This is also sine t into cos t. Lambda c1 outside, value for integration is nothing but 1 minus cos 2t divided by 2 plus this lambda c2 upon 2. I have to multiply and divide by 2 so that I can get the value here. Sin 2t is nothing but 2 sin t cos t. I have multiplied divide by 2. Okay, now let me solve the value of integration. Integration of 1 is t minus integration of cos is sin 2t divided by 2 okay plus lambda c2 divided by 2 integration of sine is minus cos 2t divided by 2 within the limit 0 to 2 pi. Is equals to c2 is equal to lambda c1 upon 2 is 2 pi minus 1 by 2 outside. What I get inside this is sine 4 pi minus sine 0 plus lambda c2 divided by 4. Actually this plus this negative sign we can merge here. Lambda c2 upon 2 into 2 4. So what I get cos of 4 pi minus again p0 cos 0. Again we know the value of sine and cos. This term will be 0 since sine n pi is 0. This is 0, this is 0, the resultant is 0. Here also cos 4 pi is 1, cos 0 is 1, 1 minus 1, again it is 0. This 2 get cancelled and we get the equation c2 minus, c2 is equal to lambda c1 into pi. You can write this as lambda c1 pi minus c2. This is our equation B. What is our A? C1 minus lambda c2 pi. C1 minus lambda c2 pi. This was our equation A. It was arrived from our equation 4 and it was arrived from equation B. Correct? Any doubt up to this?
No, ma'am.
Okay. If you have written up to this, what you have to do in the next, if you want to find out a non-trivial solution, so what will be the resultant? You have to write down the statement. For finding the non-trivial solution, value of a d lambda should be equal to 0. Okay. So let us find out the determinant. What is the coefficient of C1? Lambda into pi. Coefficient of C2 is minus 1. Coefficient of C1 is 1 minus lambda pi. Coefficient of C2 which is equals to 0. Let us multiply. When we have to solve this determinant, it will be lambda square pi square with negative sign plus minus minus will be plus 1 equal to 0. We can write this is lambda square pi square is equal to 1, which means that the value of a lambda we can write it as 1 upon pi square, which implies lambda is equals to plus or minus 1 upon pi, and hence the result. For this value of a lambda, we get the non-trivial solution. Okay. Have you written up to this?
Yes, ma'am.
If yes, let us now go for the case 1. You have to go for case 2. Let us go for case 1. What is a case 1? For lambda is equals to 1 upon pi. Right? Now we have to find out the eigenfunction corresponding to this eigenvalue. Okay. So right here put lambda 1 in equations. What are those equations we have obtained is A and B. Okay, put value of lambda in equations A and B. Okay, what is our equation A? C1 minus lambda C2 pi. C1 minus lambda C2 pi is equals to 0. Next is lambda C1 pi minus C2 equal to 0. Okay, let me put up the value of lambda 1 as a 1 upon pi. C2 pi equal to 0. Lambda, okay, what is the value of a lambda we are substituting is 1 upon pi C1 pi minus C2 equal to 0. Okay, let us solve these equations simultaneously. So what is the equation we get is C1 minus this pi get cancelled. C1 minus C2 equal to 0. And what about this? Again this pi get cancelled. We get C1 minus C2 equal to 0. From these two equations, what I get the resultant? C1 is equals to C2. Correct?
Yes, ma'am.
So what you have to do now? We have to substitute this value C1 is equals to C2 in the equation 2. What is our equation 2? We have obtained this y of x is equals to what is our equation? Lambda C1 sin x plus lambda C2 cos x. H है ना equation?
Yes, ma'am.
Where is our equation 2? We have obtained lambda C1 sin x, lambda C2 cos x. Okay, simply we have written the values of C1 and C2. These are nothing but the integrations. Here we found the value of C1 is equals to C2. So hence we can write wherever you are having C1 you can put it C2. Okay. If I take lambda C2 outside, inside the bracket I will have sin x cos x. Correct? C2 is a constant, right? And here we are working for lambda equal to lambda 1, which is equals to 1 upon pi. So here we have to substitute the first one. You can rename this as y1 because since we are working for first value for lambda. So corresponding to lambda 1 equal to 1 upon pi, we get y1 is equals to c2 upon pi sin x plus cos x. और in another way you can write c2 हे काय आहे तुमचा एक constant value है ना c2 upon pi का we can substitute some constant number ना c2 upon pi that will be some another constant. Let me rename this as 1 to have a simplification. Or you can write as it is only c2 upon pi into sin x plus cos x. So you can write for corresponding to lambda 1 equal to 1 upon pi, there will be eigenvector is sin x plus cos x. Okay. If you are not having a doubt, please try to find out for lambda equal to minus 1 upon pi. That means you have to write down case 2 equal to lambda 2 equal to minus 1 upon pi. Put the value for lambda 2 in equations A and B and solve it and tell me the solution. That means you have to tell me what is the relations between C1 and C2. Okay. Solve it fastly and tell.
y2 of x will be sin x minus cos x.
Sin x minus.
Cos x.
I think you have got the value of C1 is equals to minus C2, no?
Yes, ma'am.
So corresponding to lambda 2, we get the y2 is sin x minus cos x.
Yes, ma'am.
And it is clear from the lambda itself. If it is going to substitute lambda is 1 upon pi, you get C1 is equal to C2. And if I substitute lambda equal to minus 1 upon pi, it will be obviously C1 will be exactly opposite of C2. C1 is equal to minus C2. Okay, try to solve it here only and tell me the values of lambda. Yes. Have you solved it? Please, you can tell me what are the values of lambda. येतंय का सॉल्व करायला?
Ma'am, whether lambda is 1 plus minus I root 80 divided by 9.
1 plus or minus?
I under root 80 divided by 9.
No, it is wrong. Can you please tell me what the
Madam,
equations you have obtained?
madam,
Lambda square 9 lambda square minus 2 lambda plus 9 is equal to 0.
9 lambda square
Minus 2 lambda plus 9 is equal to 0.
Yes, anyone else can answer this?
madam, lambda is equal to minus 1 by 3.
No, everyone is getting some different
Ma'am,
answer.
lambda is equal to -3. It is a repeated root, I think.
Correct. Lambda equal to minus 3 is a correct answer. Okay, those who have solved, just check your equations. Okay, Eras, you can check out if you are having the correct answer. It will be the first equation is 1 minus 2 lambda by 3 C1
Yes, ma'am.
plus lambda equal to 0. This is what the first equation we got. And the second one is lambda C1 minus 4 lambda by 3 plus 1 into C2.
Yes, ma'am.
Okay. Those who haven't written this, or rather you don't get the answer, for them I am writing it is 1 minus 2 lambda upon 3 into C1 plus lambda C2 is equal to 0. This is what of first equation. And the second equation we have is lambda C1 minus 4 lambda upon 3 plus 1 C2 equal to 0. This is the equation B. जर हे इक्वेशन आले तुमचे सॉल्व केल्यानंतर इक्वेशन 3 and 4 तर ओके, अदरवाइज इट इज रॉंग. And what are the values of lambda we got is -3, that is a repeated. Okay, try to solve once again.
Yes, ma'am.
Okay, now let us go for the next point, that is solution of Redol integral equation with separable kernel, but here it is not a homogeneous case. Up to now we were studying about homogeneous Redol integral equation of second kind, correct? We have studied what is a method for solving Redol integral equation of a second kind, rather it is homogeneous and in case of a separable kernel. So what is a method? We have seen in detail. First we have to put up the values of C1 and C2, then multiply by G1, and then we have to solve the all those A1, A2, A3 up to AN. All those equations we have to solve and we can get the solution in case of homogeneous Redol integral equation of second kind with separable kernel. Okay. The same thing we have to see for non-homogeneous. Non-homogeneous Redol integral equation of second kind with separable kernel. What is a separable kernel? The kernel can be written in the form of sum of, that is in the form of sum of finite number of terms, hence summation is up to n finite number of terms of functions of x only and functions of t only. Okay. Now as it is a non-homogeneous, so what will be the equation? As it is a second kind, g of x is 0. Sorry, g of x is 1 and it is non-homogeneous, so there will be some function f of x plus lambda integration, as it is a Fredol, upper and lower limit are constant, and k of xt, the value of k of xt is nothing but your separable kernel. This is what our equation 1, which is a given equation. Now let us substitute the value of our kernel k. Integration a to b, summation I runs from 1 to n, fi of x into gi of t, y of t, dt. This is what equation 2. Okay. Now what you have to do, we have to take the terms of x outside the integration, because since the integration is with respect to t. Okay. What we have done in the last method, the same method we have applied. Instead of having a value of f of x, here we have f of x is 0. Again, we have to follow the same procedure, correct? Let me name this as equation 3. Now, we can have the y of x is equals to f of x plus lambda summation over I 1 to n fi of x into, now we can write it as ci, since gi for different values of I we get the different ci. You can name this as 3 only, and what is the value of ci is integration a to b gi of t y of t dt. This is what where value of a ci is. Now let me name this as say equation 4. Correct. Now what is the method we have applied for the last one? We have multiplied g1, g2, g3 for this equation. For every step we have to multiply by g1, g2, g3 and we have to apply the integration within the limits a to b. Okay. Multiplying equation 3 by g1x, g2x to so on gnx successively and applying the integration within the limits a to b. Okay. The same procedure we have followed for our first method, we have to do the same thing here. Okay, let me write down those equations. First multiplication is g1 of x and integration is within the limits a to b. And here y of x already we have the integration with respect to x is equals to integration a to b, f of x was there. We have to multiply by g1 on both sides. Hence we have to multiply for f of x also. Summation over I 1 to n ci, correct? This integration we have to multiply by g1 of x. Integration fi of x. Again we have to multiply by g1 of x. Integration is with respect to x. Okay. This is what our equation a1. Whatever the method we have applied just from now, we have to do the same procedure. Integration a to b g2 of x y of x dx is equal to, इथे 0 होता ना आधीच्या इक्वेशन्स में, f of x. Now we have to multiply by g2 of x dx plus summation over I ci outside integration a to b fi of x into the second multiplier is g2 of x. This is our say equation a2. Similarly, we have our last equation is integration a to b gn of x y of x dx is equal to integration a to b f of x. The multiplier is gn of x. Integration is with respect to x plus summation over I 1 to n ci integration a to b fi of x. The last multiplier is gn of x. Integration is with respect to x. Okay? Any doubt up to this? The same method we have done.
No, ma'am.
If not, let us. Can you tell me what is the next step we have done for the last method? काय केलं होतं हे substitute
Alpha ji.
alpha ji we have done. Here the value of ci is also given to us. Equation 4. What is a c1? Integration a to b g1 y of t. c2 is integration a to b g2 y of t dt. Equation 4. Okay. So here from this, here these equations we have LHS g1 y of g1 of x y of x dx, g2 of x y of x dx. So what are these LHS? These are nothing but your CIs. From equation 4 you can see C1, C2, C3 and so on. Okay. The next thing we have done is in the last method we have written the value of this. This is fi of x g1, fi g2, fi gn and so on. Right. So here this fi is here and g1 is varying, g is varying. So here we have renamed this as alpha ji. But here we have to rename this one also. Here this term was 0 initially. Okay. Here what is the variable? That means which one is varying, g1, g2 and so on. Okay. So for that let me rename, you can write here using equation 4 in LHS. And from the last method, we have done alpha ji is equals to integration a to b fi is as it is and gj of x dx. Okay. The next thing we have to do is we have multiplied by f of x into g1. So this term we have to write down some another constant because again the integration is within the limit a to b. Hence we can apply that. Here we can get the value of this term is integration a to b. This f of x is fixed out and values of g is varying. Okay, for the different values of j, you will get different constant. Okay, any doubt here? The first, that is LHS is C1, C2, C3 and so on. The second term in the equation is this is B1, that is beta 1, beta 2 and so on. Okay, G1, G2 जसं वेरी होणार आहे तिथे beta 1, beta 2 इथे येणार आहे. इथे काय असेल जे काही आपण फर्स्ट मेथड मध्ये लिहिलं ते कारण की इथे इंटिग्रेशन विद इन लिमिट a to b आहे ना. So here we'll get it is alpha ji. Okay. I is fixed out and value of j is varying. Okay.
Yes, ma'am.
If it is okay, let me write down these equations once again as C1 is equals to what I get the first equation is beta 1 plus the summation lambda outside summation over I 1 to n. So first we can write it is Ci as it is alpha 1i because I is fixed here and j is varying alpha ji. G vary hota na g1 g2 and so on. Okay. So let me write down this equation as now again we have to do the same procedure. C1 if I am going to take common it will be 1 minus lambda alpha 1 1. Okay, minus lambda C2 alpha 1 2 minus lambda C3 alpha 1 3 and so on. The last term we get it is minus lambda Cn alpha 1n. What is there here? It will be nothing but beta 1. आधी काय होता इथे 0 असणार ना. Here the value is 0. Why? Because f of x was 0. But here f of x is there, so hence we get the multiplier g1 also and integration also, and then we get the some constant b1, beta 1. Okay, now we will name this as some equation say b1. Similarly, we can write the another equations. Let me write down for c2. What will be the equation for C2? Minus C1 lambda alpha 2 1 plus C2 if I take outside will be 1 minus lambda alpha 2 2. The last term is minus lambda Cn alpha 2n is equals to beta 2. This is our equation B2 and so on. Now those equation after putting the values of those constant term we get it is minus C1 lambda alpha n1 minus C2 lambda alpha n2. The last equation we are writing. What is the last equation? If I take Cn outside, 1 minus lambda alpha n is equals to beta n, and this is our Bn equation. Okay, the equations A1, A2, A3 up to An have been now converted into B1, B2, B3 with the help of these conditions. First is LHS is substituted by equation 4, that is a value of Ci, and alpha Ji we have substituted, and next is beta J. Okay, now we have got the n equations in n unknown, but in this case, we are not going to get the solution by homogeneous case. Initially it was Ax is equal to 0. इथे बीटा नव्हता ना आधीच्या केसमध्ये. Now here we have Ax is equals to b. Now again I want to ask you whether you have studied simultaneous equations solution. There are cases no solution, zero solution, unique solution, infinitely many solution, augmented matrix. आठवते का?
Yes, ma'am.
In this case, we have to write down those conditions, right? Here we have to study many cases. The first case that we are going to study is d lambda not equal to 0. D lambda not equal to 0 असेल तर काय येणार आहे? Obviously we'll get a zero solution, right? Right, Ax is equals to b. Sorry, no, we are not going to get a zero solution. In this case, we get zero solution. If determinant of A is 0, we get non-trivial solution. And if determinant of A is non-zero, we get a trivial solution. But here, in this case, coefficient matrix, if it is equal to 0, and if it is not equal to 0. If it is not equal to 0, that means value for d lambda, if it is not equal to 0, you will get a unique solution. आठवत है ना? The coefficient matrix, if it is not equal to 0, then we get a unique solution. That means the values of those equations b1, b2 up to bn, there exist a unique solutions for those equations. Okay. Now let us go for the case 2. What is a case 2? D lambda equal to 0. That is the coefficient matrix is equals to 0. In that we will have many situations. Now let us discuss the situations. Okay. What will be the situation? The first situation we can consider is when f of x is 0. f of x 0 असेल तर कुठली केस येणार आहे तुमची आधीची केस ना?
Yes, ma'am.
This case we have studied homogeneous. So no need to study this case. Okay. This is what a situation 1, and here this is a case 1, and this is case 2. Okay, the case 2 is clear. If determinant is non-zero, you will get obviously a unique solution for non-homogeneous case. But for homogeneous case, you will get a zero solution. इथे काय मिळतो तुम्हाला? Zero solution. Okay. But here you get a unique solution since we have the value of b. For the situation 1, if f of x is 0, we get the case we have studied already, the homogeneous case. Okay. In that also we can again write down the sub cases as d lambda 0, d lambda not equal to 0. You can write or you can skip, or you can say that it will be just like our case for a homogeneous. Okay, what will be the case 2? In the case of d lambda equal to 0, no? The second case we are studying. Okay, what is a situation 2 when f of x is non-zero? Okay, if f of x is non-zero, then we have a non-homogeneous case, right? But what is the condition? In the situation 2, we have the condition integration a to b gi of x into f of x equal to 0, correct? No doubt f of x is non-zero, but this integration may be 0, correct? F of x is non-zero, but the values of those integration may be 0. We are just discussing the cases. Okay, but we have f of x is non-zero, but this is what our situation 2, in which f of x is non-zero, but the value of integration is 0. Okay, so if value of this integration is 0, what is these terms? These are nothing but your beta j, na? Right? Beta j is f of x, gj of x. Okay, see here, these f of x, g1, f of x, g2, f of x, gn, if all are 0, f of x not equal to 0, but the value of integration is 0, which means that this term is nothing but your beta j. If it is equal to 0, again we reduce to our ax is equal to 0 case. Beta j 0 असेल तर ax equal to 0 येणार ना. Beta j if it is 0, here there will be no term. Right? And we will have another case, that is situation 3, we can say, in which f of x is non-zero as well as integration a to b gi of x into capital F of x is non-zero. In that case, we reduce to ax is equals to b. Now here we have to study those cases. Those who don't remember, I was thinking that at least you should read that, whatever you have studied in BSc. Those who are having a doubt, you can write down those cases. For non-homogeneous case of simultaneous equations. First case, rank of a matrix A is equals to rank of a matrix augmented matrix AB, and if it is equals to number of unknowns, what are the number of unknowns? N, or rather we can say C1, C2 up to so on, Cn, number of unknowns. What is the next case?
Rank of a
Okay,
matrix is the number of
second case, okay. First, we will discuss the first case. In that, we have a unique solution. Okay, that is value of determinant of A is non-zero, and we get a unique solution in the first case. Okay, let me go for the second case. What is the second case? When the rank of a matrix A is equal to rank of a matrix B, that is AB, augmented matrix, but it is equal to some R which is less than number of unknowns. And in this case, we get a infinite limit. Since single equation in more than one variable, single equation in two variable, single equation in three variable. In that case, we get infinitely many solution. And if Ax is equal to 0, we get the 0 solution instead of getting the unique solution. Correct? Okay, in this case, now the third case will be when B is 0. What will be the case in B is 0? We get the trivial solution, and for non-trivial solution, what will be the resultant? We should have the value of determinant of A should be 0. Okay. So these are the cases, and if you want to solve the system of equations in the form of Ax equal to B. Okay, let me repeat once again what we have seen. This is what a second case in which we are going to study non-homogeneous Fedol integral equation of second kind with separable kernel. What is a separable kernel? It is nothing but a sum of finite number of terms of functions of x1 and t only. Okay, next is we have written this equation, we have substituted the value of t of xt, the terms of x outside the integration, since integration is with respect to t, and substitute the value of this integration is some constant, since the integration having the limits, both limits are constant. Then what you have to do, we have to just multiply our equation 3 by g1, g2 and so on, and then whatever the equations you get, a1, a2 up to so on, and here we have to rename those integrations with some another constant term, that is equation 4 from all LHS and alpha ji and beta j. After that, we have to write down the equations beta 1, beta 2, beta n in terms of lambda, and then we can have the cases. In the case, we can have that ax is equal to b, we have the case determinant of a not equal to 0, you will get a unique solution. And if determinant of a is equal to 0, we have the different cases. For f of x equal to 0, the situation 1 tells us that it will be our homogeneous case. And in situation 2, f of x not equal to 0, but value of integration may be equal to 0. Again, we reduce to a homogeneous case. Now, next one is, rather we can say homogeneous system of linear equation. In the situation 3, we can have both are non-zero. Then we can solve for a non-homogeneous case. And in this case, you have to use this condition. You have to find out the rank of a matrix, say rank of matrix AB, and if it is equal to number of unknown, then you get a unique solution. And if it is equal to some rank of both, if it is equal to some value r, but this value r is less than number of unknown, that means suppose you have system of 3 by 3 say, but here you get the rank of them is equal to 2, so 2 is less than number of unknown, and hence you get the infinitely many solution. Okay, any doubt in this?
No, ma'am.
No, ma'am.
Okay, if you are not having a doubt, let us solve an example. You have to solve it with me. See, why I am taking 2 lectures, because I have to cover the numerical analysis also. Find the solution of integral equation. Write the question. Find the solution of integral equation. What is an equation we have provided? Y of x is equals to e raised to x plus lambda integration 0 to 1 2 e raised to x e raised to t y of t dt. Okay. While in exam, you have to verify which kind this is. If it is f of x is non-zero, you have to follow the second method. Okay, that we have seen just now. Okay, let us follow the things. What you have to do now? Again, we have to follow the same procedure. Plus lambda, this 2 lambda I can take outside, e raised to x outside. Inside the integration, we will keep the terms which are involving t. Okay. Now value of this integration we have keep it as some constant c. Okay. What is the next step? For the value of c we have to write. This is what integration 0 to 1 e raised to t y of t dt, which is our equation 3. Now what is the next step? Use equation 2 in terms of t in equation 3. Using 2 for x equal to t in equation 3 for solving, and we have to get the value of a c. Integration 0 to 1 e raised to t, we have to substitute the value of a y of t, that is nothing but e raised to t plus 2 lambda e raised to t into c and dt as it is. Okay. C equal to integration 0 to 1. This is what e raised to 2t, e raised to t into e raised to t, plus 2 lambda c as it is, e raised to 2t again, okay. Let me solve this integration. This integration is easy to solve, no? C equal to integration of e raised to 2t is e raised to 2t upon 2 plus 2 lambda c integration 0 to 1. Sorry, value of integration will write directly. This is e raised to 2t divided by 2 within the limit 0 to 1. E raised to 2 minus e raised to 0 divided by 2 plus this 2 can get cancelled, lambda c e raised to 2 minus e raised to 0. Hence we get c is equals to e square minus 1 by 2 plus lambda c e square minus 1. If I take value of c outside, it will be 1 minus lambda e square minus 1. If I take a c outside from this, it will be 1 minus lambda e square minus 1 is equals to e square minus 1 by 2. Correct?
Yes, ma'am.
Yes, ma'am. What is the next step? C into 1 minus lambda e square minus 1 minus e square minus 1 divided by 2 is equals to 0. Now you can find out the value of a c. Okay, what is the value of a c from this step I can write? What is the value of a c we can write is, this is e square minus 1 by 2 as it is divided by 1 minus lambda into e square minus 1. This is what a value of a c we have obtained. Now put the value of c in above equation. In which equation we have to put this? In equation number 2. Okay, putting the value of c in equation 2 we get. Okay, what is our equation 2? Y of x is equals to e raised to x plus lambda 2 e raised to x into c. E raised to x plus 2 lambda e raised to x into the value of c here we have to write. And hence the result. Okay. You can again simplify this. You can simplify or you can put it as it is. And hence we get the solution. Okay. Ma'am, here we cannot find the value of lambda.
We can find out, but actually what is the problem? If you want to find out the value of a lambda, what is the problem? Let me write down here. Okay. In this step, what I have to do? I can write this as 0 to 1 e raised to t or 2t outside 1 plus 2 lambda c. No doubt we'll get the same thing here. But if I want to find out the lambda from this equation, okay, how you are going to find out the value of lambda from this equation?
Ma'am, lambda comes in terms of c and e.
No doubt it will be in terms of c and e. But we have to also find out the value of c now. Up to now, whatever the examples we have seen, after finding the values of lambda, that is lambda 1, lambda 2, and then we are going to substitute this in equation a and b, and then we are solving to get the values of C1 and C2. First we got C1 equal to C2, and the second one we got C1 is equal to minus C2. So first we should find out the value for lambda, but which should not be in terms of C, correct? Because here, if you remember the last example, we were having two equation. If you have two equation in two unknown, you can solve. But how you are going to solve this equation? To get the value for lambda, which is not in terms of C. Okay. So that is somewhat complicated. So hence what we have to do, we have to just find out the value of C here, and you can substitute the value of C in equation 2, and hence you can say that this is what a solution. Okay.
Yes, ma'am.
If you're not having a doubt, you can leave the meeting and you can join the next lecture at 1:30.
Thank you, ma'am.
Thank you.